So I do 10 minutes intro, and then you want to take the speech. All right. Good evening. So why don't we all grab a seat and we can get the meeting started. So welcome everyone for our August IEEE Consumer Electronics Society meeting. So for the people who actually, usually it's the young professionals who are into the Twitters, and these are the hashtags that you can use, and then you can post pictures and comments. The current officer for this year, my face always looks really tanned once you come out the display. So I'm Joseph Hui, I'm the chair. Ranjin, who is back there, he's the vice chair and also helping out with our marketing site. Jim usually is also here. Some of you come pretty frequently, but Jim just took a job with a startup, so right now he's, some of you work for startup, right? There's a lot of time that he has to put in, so Jim's not here tonight. And then secretary is Shamir in the back. And then we also have Avery, who's the program chair. Avery's not here. And Eric Kwan Lee, actually, it's pretty tough for him to come down. He actually works in downtown San Francisco. So he helped us with the alliance partners of typically, if we do joint event with non-IEEE groups, he's responsible for coordination. And then El Doji, also not here, but he's helping out with membership. So first of all, the two people, I think they're still outside. Oh, Steve is here, and Anil, so let's give them a great hands for helping out. So basically is they the one actually spend a lot of time and effort to get the badges ready, because with the arrangement with NVIDIA, that's why we require people to register, so that it makes the check-in process faster. And then we also have two co-sponsor society for this event, and Computer Society and also Signal Processing. So let's give them a hand. That's why we have so many people here. As part of the financial, so in order for us to provide you with free pizza and drinks, we do get some reimbursement back from IEEE headquarters. That's why we always ask how many IEEE members. So just roughly with a show of hands. Did you count, Shamir? Can you count that fast? So roughly about, I think, 60–70% of the people. And how many are CE members? Probably similar type. Yeah. So one of the characteristics of CE society is that we have pretty loyal membership. So a lot of the regulars will come every meeting. And the next thing is. The reason is, so you have to be IEEE member first, not to join any of the chapters. So consumer electronics, If you look at the way we set the tier pricing, so if you are a non-IEEE member, you pay $10 per meeting you attend, and then if you're a CE member, if you come to more than 4 meetings, you already get, because for the non-CE member, we charge $5, unless it's a co-sponsoring society member. So if you attend more than 4 meetings, you already get your membership paid off. And the benefit is for basically, for recruiting, and I'm going to the benefit of IEEE. So for IEEE members, and now you are not aware, if you recruit IEEE members, you can actually earn dollars that can be applied to your membership renewal. So it's $15 for each professional member that you recruit, and $5 for the student members, and $2 for the student members. And also you get the magazines. These are, each chapter has, most of the chapter has its own magazines, in addition to Spectrum, which you get through this IEEE membership. So you also get the CE magazine, which is the being nominated as the winner of the Regional 2016 STC Technical Communication Awards. And also you get the magazine from I3, which is published by the Consumer Technology Association, which puts out the show in Las Vegas called Consumer Electronics Show. So we also have a lot of professional activities for the consumer electronics in addition to, so we do our own meetings, we also do joint meetings, and every now and then we also have workshops. Because we're all volunteers, so a lot of the activities is based on the volunteers' time and availability. And then we also have international conferences around the world. So I think we already have all the speakers lined up for the rest of the year. So if you have additional speaker topics that for 2018, please send them to Avery. And if you know any other organization, ACM or other group would like to partner with us on events, now you can contact Eric. And then for upcoming local events, so we have eGrid. So that eGrid is the one that you want to always bookmark on your browser. Now it has listing of all the IEEE meetings, not just consumer electronics, computer society, signal processing, communications. The Silicon Valley Wearable Meetup is one that I chair, and also the Smart Glass Meetup. There's another organization based up in Berkeley called Berkeley Sourcing Group, and they run this meetup called Hardware Massive. So they have a lot of speakers and pitch events, and usually around the Bay Area, not necessarily down in South Bay. And some of you know I co-founded Lab 360 Hardware Incubator, so we also have a meetup that we hold different type of investor event, start pitch events. Avery, I think, is an advisor of the other accelerator, Action Spot. They're based in San Jose, downtown. And then on September 14th, Product Realization Group, I don't know how many of them, how many of you have heard of them. So they actually help startup companies to get their product design and all the way into manufacturing mass production. So they have an event at their Computer History Museum, and here so we have a 15% discount code for attending. And then in October, we have the IEEE GHTC, stands for Global Humanitarian Technology Conference, and that's going to be held in San Jose DoubleTree. And the next meeting is going to be back to our normal. It's the 4th Tuesday, September 26th. And the topic is going to be on emerging wireless technologies for IoT. So the speaker is going to cover from LoRa, Sigfox, Bluetooth, BLE, all the different type of wireless technology and the trade-off in design versus power. So I think the registration is already up on the website. So any company who is hiring, you want to raise your hand and make an announcement? No company? I thought everyone, no, there's so many job openings. So anybody who's looking for full-time contract employment who wants to speak up? Arthur?
Hi, my name is Arthur Zinger. I'm a physicist and a prolific inventor. If you've got anything at the level of sensors or algorithms, or any physical level hardware problem, I'm And it's really, really important. You don't come in for a routine problem, but come in for a problem that's so important that it'll make or break a company. I've pulled rabbits out of the hat many times. Thank you.
All right, great. So, anybody else? Tom, you want to make an announcement?
Yeah, got a few things. One is, if you're an IEEE member, be sure to vote, because the election's going on now, ends October 2nd. Also, Joe mentioned the Global Humanitarian Technology Conference. That's going to be in San Jose. There's some cards around that are over on the table over there if you're interested in that. Find out more about it. And then a non-IEEE event that I'm putting on is the Storage Visions Conference, which is focusing on digital storage and applications for unstructured data. So that's going to be October 16th in Milpitas. So there's a card on that over there also if you're interested. Thank you.
Can I say something too?
Sure.
Hi, my name is Yolka Musada. I am an engineer, currently director of application, a startup, but I'm also vice president of Silicon Valley Engineering Council. I want you guys to be part of us. We have a lot of events. We have an open house coming soon to announce our winners for the Hall of Fame. And we have engineering banquet in February 15. You can all welcome, and we provide scholarship, Hall of Fame nomination, and a lot more things. So we can always work together to make a better world.
Just let me add a little bit. So Silicon Valley Engineering Council is the umbrella organization for IEEE, ASME, CAME, about 15, 18 societies. Right?
Yeah, you can look it up on our www.svec.org, and you can click on the members. Then you can see all engineering organizations all under us. We are the hub. I am the current vice president of the organization. So you are all welcome to work together with us, and we can work together for all events so we can share knowledge and wisdom and work together, volunteer to make the world a better place.
So in addition to the Santa Clara Valley section, who's members of Computer Society, Consumer Electronics Society, and I think Communication Society, we're all separate members to the SVEC. And one of the things, I know you remember, like over 2 years ago, through the connection with SVEC, the Consumer Electronics Society partnered with ASME, had a student venture capital night at the Santa Clara University.
Sorry, I missed the previous slide. I didn't expect the job opportunities to be coming along. So I come from Nord Labs. We are a startup in Mount View. So we are actually looking for great deep learning and computer vision engineers. If you guys are interested, then you can send your resume to jobs@nord.com. NOD, Nord.
NOD.com.
Yeah, jobs@nord.com. Yeah. We work on some of the interesting challenges in the motion tracking, like this LAM and other pieces. I can't talk here much, but feel free to explore.
Okay, so I'm also now getting in near the end of the year, so I'm also do volunteers drive. So we're seeking additional volunteers to help with the speaker program, and also we'd like to have, in the past I think Shamir has organized a workshop that worked very well for us, but it takes a lot of effort. So, and also I think one of the things that went very well was the Santa Clara Valley section actually held a summer social, and that allowed us to get together in a different non-technical meeting environment, so we can actually meet each other and learn a little bit about how we can work and partner. So the goal, and also for membership development. So the goal is we missed an opportunity because we didn't compile the submission for the outstanding chapter a few years ago. So we actually had the most number of people attended our event. So there was some statistics that based on the result, we should have been much closer to winning that award. So next year, we're going to put in a concentrated effort to put together a very good program for the whole year so we can be nominated for the outstanding chapter. So if you're interested to help, please send me an email. The next thing is I'm also running for the Board of Governors for 2018. And this is my, basically this, the IEEE vote, as Tom mentioned, is going on now through September 5th. There's more information on the website that I put in than what's allowed on the voting site. So I'm looking for your vote, and hopefully I'll get in this time. So tonight's topic, Chronos standard for neural network acceleration and deployment. And I think the topic about neural network acceleration is just very fascinating. I know I just spoke with Radha a little bit earlier. Some people came in and actually was asking him about what's his talk like. I said, well, Chronos Group might not be that well known by a lot of people, but at least the topic itself, a lot of people, I think, are attracted by the topic of neural network acceleration. So the speaker tonight, Radha Guthrie, is a longtime friend of mine from, actually he's the one that actually revitalized the Signal Processing Society several years ago. And so he has been with AMD for how many years? Yeah, 12 years. Focusing on the development of computer vision and neural network accelerations using GPUs. He has extensive background with software design and performance tuning with various computer architecture from general purpose DSP. That's why he's very much involved with SPS and also different type of processors. And he's a member of the Chronos OpenVX and NNEF working groups and the editor of OpenVX Safety Critical Specifications. And he's also a member of SMPTE Video Compression Standardization Committee. And he's an active member, as I mentioned. He's inspirational in reviving the SPS Society. SPS win something, right? SPS won some awards? Oh, just you. Yeah. So, so for him, actually, he's the winner of the Outstanding Leadership and Professional Services Award for the Central Area. So maybe SPS will also try to compete to win the Outstanding Chapter next year. All right, so without further ado, let's welcome Radha. Thank you.
Can you guys hear? Oh, perfect. Thank you. Thank you, Joseph. See, let me get started. Just a curious question. How many of you are aware of Chronos standards? So that's good. Okay. So I'll go over some of the standards what Chronos does in the middle. First, I'm going to get started. The topic is basically about Chronos, we kind of standardize the APIs and formats that are to help industry collaboration. So I have a couple of slides to show for that. Something wrong with this. Joseph, I'm going to need some help. Okay. This was the full screen one. Can't do it. Can't do it. Okay. it's not showing me the presenter mode. Okay, thank you. So I'm going to talk about why we need a standard at this time. And I will be specifically talk about two standards from Kronos, which is NNEF for Neural Network Exchange, and the other one is for OpenVX for Vision and Neural Network Acceleration part. Right? And here is a simple example. This is just a small diagram to show you what I'm going to be talking about. Pure focus is going to be once you have a neural network trained, how do you deploy it? I'll be focusing primarily on that, not on the learning part. This learning part, the better talks for that. Right? So the two terms that I want to introduce here, one is I'm going to use the word neural network architecture to refer to kind of the networks such as whether you're using AlexNet, which has particular convolution followed by pooling certain kind of layer architecture. That's what I'm going to call it as neural network architecture. And when I say network model, it means basically the weights, whatever you have tried using that architecture, whatever like TensorFlow or Caffe, whatever the output, that's what I'm going to call it as model. So why standards? So let me start looking from neural network from end-to-end workflow. And you see, the problem always starts with the data set. So if you have a problem for recognition, you start with data set, creating a data set and annotating them. So that kind of defines your problem. And it's a very complex problem. It requires a lot of domain-specific knowledge in terms of which area you're applying. So that's the first thing you're going to pick. And the next thing is once you have the data, you need to pick a network architecture that you want to use, what kind of a neural network you're going to use for training. And then once you've done those two, then the third part comes is picking up what kind of a framework you want to use for authoring or training your network. And there are a lot of possible solutions that you have. You can use the TensorFlow that's recently quite popular from Google, and you have other alternatives. Microsoft has their CNTK, and Amazon has MXNet, and there's Caffe too that Facebook has been doing a lot of work with. There are a lot of solutions. I just picked a couple of them here. And once you have picked some kind of a platform, then you need to decide, well, are you going to train it on your desktop? Are you going to use the cloud? And what kind of hardware you want to use? There are a lot of possible solutions you have. You could pick, NVIDIA has been accelerating a lot of the neural network frameworks. Learn on NVIDIA, they've been started very early. And now there are other alternatives. AMD has released a Radeon Instinct, MIOpen. That kind of gives you, 25 teraflop hardware, and that's another alternative. Intel has their own alternative for acceleration. I keep hearing every other week somebody else announces saying they are working on new hardware for neural network acceleration. So you start seeing more and more because the demand is increasing. And I'm not going to be talking about the learning or that part. I'm just going to move to the next one. Once you train something, you got a trained model. Once you get a trained model, you could just use some third-party tools on it to refine it. If you want prune it, if you want to optimize something and go back, retrain, there's a big flow that works on. And that's when some of the problems that we're going to highlight are going to start. Is once you have a trained model, now you want to build an application, vision or AI application, which takes this model and tries to use some kind of inference engine that runs on various hardwares that are possible, right? Whether you want to deploy it on a mobile application or some kind of a closed embedded, such as a robot or a car, or you want to deploy it on desktop, for example, if you want to use it under gaming, or somewhere in the cloud, like Siri or some other applications like that. And you have a lot of variety of hardware possible solutions there. If you try to look at this problem, that every place you have a lot of choices to make. And that's what creates a problem of fragmentation. If you try to see, there are about 10, 15 possible learning frameworks that you can use, training frameworks that you can use. And there are inference engines too. NVIDIA has TensorFlow, and Intel has CPSDK, and AMD we have recently released our open source project. There's a OpenVX-based inference part. And you try to look at all these, there's a mapping many to many. Every framework has their own internal representation. And every inference engine has their own internal representation. Now, if you look from an authoring perspective, and if they want to support all possible inference, now you can see many to many relationships. There's kind of a lot of fragmentation there. That's one problem we have to do. Another one is if you're trying to build an application, Let's say if you're trying to build an application on a PC, for example, and you have hardware, it could be Intel, it could be AMD, it could be NVIDIA, right? You want to use an inference engine, now you have multiple things. From an application perspective, now you have to write an application that handles each of those APIs, each of those internal formats. And that's another fragmentation problem. It kind of complicates the application developer scenario. That, sorry.
Can you explain a little bit of the inference engine? Like what example you are referring to as an inference engine?
Okay, so the question is, what is an inference engine? So inference engine, let me go back to this diagram. Yeah. Inference engine, what it basically takes is, once you train a network, you have the network architecture and all the weights. All the inference engine does is just takes those weights. Let's say if you're feeding a convolutional network that takes an image and just runs through that forward path and gives you the result. And what inference does is it kind of optimizes very well because it knows all it has to do is running the forward path. It can do a lot more optimizations in that path. That's all.
You are talking about.
Excuse me, what if there is a feedback loop?
Feedback loop in the inference.
Yeah, in the graph. So what happens in the inference engine? You
So-
said forward path.
Yeah, so when I say in the neural network forward path, I'm kind of referring to as CNN, convolutional neural networks, and there are RNNs and LSTMs which have some kind of feedback loop, but it is very well defined. You have a matrix, every time you flow through a data, the data gets updated within, and it kind of stays there. Right? But it is not learning, that means you're not modifying any of the weights in the one part of the convolution. In case of LSTM, there's some data that gets updated as it learns through it. Now, what is Kronos? Kronos is an industry consortium, and we have more than 100 players, companies that are contributing to it, working towards it. And the goal basically is to build a royalty-free open standards. And if you look at most of your phones, everything are familiar with, WebGL, OpenGL. Probably you're kind of familiar with those two words. They are coming from Kronos for the graphics part. And every phone, every device, I think there's more than 1 billion devices that support WebGL today. And in addition to the WebGL, there's also GLTF, which is a kind of a file format. So there are two kinds of things that Kronos does. One is an API for hardware acceleration. Right? So you can see at the bottom there's a silicon, on the top there is a software. So it kind of tries to come up with an API so that application developers don't have to worry about what hardware it is running on. They just use a common API to access the underlying hardware acceleration in there. And also GLTF is another one that we created for the graphics side, where you can share your 3D assets. So when you have a lot of web apps, you could kind of use GLTF so that depending on which hardware it runs, it gets automatically accelerated for decoding and displaying. And on the right, there's OpenXR is a new standard that we're working on, which is for AR and VR. That's still work in progress at Kronos. OpenCL is for computation layer for GPU acceleration. That was created for that. Now they are actually, it can be used to accelerate on CPUs. There are FPGAs, there are a lot kind of hardware that you could use. If the workload is data parallel, you can use OpenCL for accelerating. So two things that I'm going to be talking today are going to be OpenVX and NNEF. OpenVX, we have already released one spec, 2014. We're working on the next ones. NNEF is still under progress. The focus of OpenVX is vision acceleration. And vision nowadays include neural networks. So we have added some primitives to accelerate neural networks also. NNEF is neural network exchange format. It is basically a data format that people can represent any kind of network topology weights in one format that can be exchanged between frameworks into the inference. Right? So now, let's look at the problem that we talked about earlier, solving the fragmentation in terms of data formats. Now, instead of many to many, now you could just create one format where all the authoring tools can write in one particular format that anybody else can read. It also means you could train partially using one framework, and after some time you can take that same data from NNEF, go back, and train it using another framework depending on whatever resources are available. And it also opens up a room for further processing for third parties. If you want to do certain kind of optimizations, they can all just use NNEF instead of trying to their tool to support TensorFlow or Caffe or any of other tools. It's kind of many to one problem. Now going to the other fragmentation from, if you try to look from an application perspective, and if you try to reach out, now OpenVX is kind of an API that you can use to reach out to any of the inferencing hardware. So application can just write their code just using OpenVX API. You just get automatically translated to underlying hardware, just like OpenGL, or WebGL, right? You just use one API. You don't need to worry about how to do little tweaks here and there to the hardware. The hardware driver will take care of it, like OpenVX. Every vendor will implement for OpenVX, and they take care of optimization for the hardware. Any questions, sir?
So how is it related with OpenCV in case you want to use?
Okay, OpenVX and OpenCV, this question comes, I have a slide at the end. I'll talk about it. Okay. OpenVX is a standard, OpenCV is not a standard.
Okay.
Right? And then you can say that OpenVX, when somebody claims, I have an OpenVX implement, my hardware is OpenVX compliant, that means you're guaranteed that functionality is available. Right? If you build an app with OpenVX, anybody who claims OpenVX conformant, your application is guaranteed to run. It's portable, not just functionally, it will also be portable performance-wise. It will give you best performance that is possible on that particular hardware. With OpenCV, you need to worry about, is it supported on that hardware, which functions are supported on the hardware. But the good thing about OpenCV is it is huge functionality. Anybody comes up with a new work, they'll try to contribute to OpenCV. It's kind of very collaborative. Now let's go back and look at the workflow diagram that we looked at before. Now, where does these standards fit in here? Usually you can use NNEF when you try to define your network architecture, or once you have a training done, you can export it into NNEF format. Right now, we're kind of focusing on the exporting from the training framework to the inference part. That's where, because people have already invested a lot of money in training some data, all we want is just kind of being able to export that NNEF so that they can use it further in the deployment flow. And OpenVX comes between the application layer and the inference runtimes, right? Now, if you try to look at general application development workflow, most of the time, all these computer vision workloads are neural network workloads. On the right, you see, you kind of give a graph, kind of direct a cyclic graph. You kind of specify the graph, and underlying implementation will look at it, run through, try to optimize the graph, kind of does some kind of a compilation, and then tries to create some data that is vendor specific. That is very critical for a neural network, especially when you have weights. You might want to kind of represent it in a format that is very friendly to your hardware. And the application doesn't have to worry about it. They just use a standard NNEF. Underneath, the graph compiler will take care of reformatting the data in a way that is friendly to the hardware. And then the inference engine will just take the data input and just translate very friendly to the hardware. Right? And that's where the OpenVX comes in. A little bit about NNEF. It is still under development. We are still looking for some feedback coming from our working group members, and kind of in the final stages we're planning to release towards the end of the year. We also formed an advisory panel for NNEF so that people from the industry who've been working can kind of contribute. I have one slide which kind of explains what they can do. And the first four, like I said earlier, the first version of NNEF is going to be primarily focusing on inference, basically being able to take a pre-trained data and export it to any of the inference engine. That's going to be our primary focus. And also, we have to define a format in such a way that it is easily extendable. If you try to see the neural network research papers, every year you see a lot of new techniques coming in. If you try to pick a standard format, that's kind of very rigid, the danger of there is now new research won't begin, and that will make the standard not usable. So we kind of try to define something that is kind of very flexible. If there's kind of new set of nodes somebody wants to come up with, you'll be able to express it in the NNEF. What else? And we have a lot of members. You can see about, I think about 20 members active in this group. When it comes to advisory panel, we want kind of experts from the industry. It doesn't cost anything other than that you have to kind of sign Kronos NDA. just to keep the IP framework in there. And what we do as part for the advisory panel is we kind of release the draft early to them to get some feedback in terms of what they see is good, if they want to add more features, what's the roadmap, how do they see it. Right? And we have the advisory panels open for other standards too, like Worker and OpenCL and SICOM. Now I'm going to talk about OpenVX, which is basically OpenVX is kind of a cross-platform acceleration for computer vision and neural network acceleration. So what's the problem we have? If you try to look at vision, there are people write their own applications independently. Sometimes there are middleware which wants to address multiple hardware underneath. Right? And also there are vision engines that they want built that can kind of address multiple hardware. It's again many-to-many problem. OpenVX, what it lets you do is all these applications to just express their problem, what kind of a functionality they want, specify that in a graph. For example, if you want to do kind of a Gaussian filter, you specify if you want to do a Gaussian filter followed by certain other functionality. And then let OpenVX layer take care of mapping it to the underlying hardware. And hardware can be of various range, complexity. If you try to look at it, there are completely programmable devices. If you look at, there are from dedicated hardware to completely programmable multi-CPU. And you see the same thing going on the power side. Very low power to very high power depending on different market segments. And to address that, what we did is basically came up with a graph level structure where you kind of specify your function at an abstract level and then give that graph to underlying hardware driver to say, go figure out a way to optimize this one and run it continuously. And the functionality basically includes not just the computer vision, it could include CNN kind of functionality. At this moment, we only have CNN, and we're trying to add other functionalities such as admins and language. Now, let's look at how the API kind of looks like. It's primarily a C API currently, and all you do is you kind of express what kind of image operations that you want. For example, this graph example that I've shown here, imagine there's a camera coming, the camera is, you have data coming from the camera, you want to kind of do some kind of a key point tracking, you want to identify some kind of key points and then start tracking to see where they're moving, kind of observe the motion in them. And first thing you want to do is a lot of this key point tracking and detection happens on just grayscale image, you don't need all of them. So first thing you want to do is kind of extract grayscale out of it. So to get a grayscale, you can specify, kind of convert it to another domain that has kind of luminance, and then extract that luminance, and then followed by pyramid or optical flow arrays. You can kind of go through that protocol. You can express your problem in terms of a graph like this, on a well-defined one. Now, underlying hardware will take care of all the optimizations in terms of how to schedule it, and some other nodes you try to fuse them. And if you have multiple hardware, it tries to execute, schedule whichever hardware is appropriate to do certain operations. For example, if it's all pixel processing and GPUs are perfect. If something is very sequential, then you might want to say on a PC, you might want to use CPU. And same thing happens on SoCs. You have DSPs, ISP in there, and then kind of a host processor. The underlying OpenVX can take care of looking at which is the right place to do the job. Now, if you try to look at OpenVX, came out from a lot of collaboration from various people and experts in the industry and also from the research. And now kind of look at it, look at the problem and say, the 4 key technologies that we could use to get the acceleration, come up with the standard API that can map well to any kind of hardware. Right? And the first one is scheduling. Right? Once you specify a graph, complex graph, how do you split the graph and across the whole system in terms of various compute units you have? That's one challenge. Another one is memory management. A lot of the times when you define a graph, you have a lot of intermediate data. You don't want to just keep allocating buffers. And if you try to program something in the OpenCV example that he was asking before, now the application has to worry about how many buffers do I allocate. If I have a long functionality, do you keep allocating buffers? You need to reuse. A lot of thought process has to go through. In OpenVX, we resolve this issue by defining something called virtual buffers. Very simply say it's intermediate data and I'm not going to access it. And underlying implementation can do whatever the heck it wants. Right? So it can kind of look at the whole graph and say, okay, all these things are intermediate data. I'm just going to allocate a couple of buffers, keep using them. That's one way to kind of reduce a lot of buffer management. There are a lot of other techniques too. Another part is kernel fusion. If you look at the previous example, if you to get something like a grayscale Gaussian filter, and all you have is RGB kind of expressing, do a color conversion, get the Luma channel, and do a Gaussian filter. If you try to look at this flow, if you have to do this in something like an OpenCV, you make each call. Every time you make a call, it does that operation. In OpenVX, it kind of looks at all the three and says, all it's doing is doing a color conversion followed by Luma channel extraction. It is not using UNV. You can simply fuse those two and optimize and say, I can just directly get Luma out of RGB doing the computation. Right? Simple dot product kind of an operation. And then immediately it says, oh, there's a Gaussian filter being done. So it can just say, on the fly, I can fetch data, do the Luma calculation, do the filtering in my local memory. So all those kind of optimizations are possible when you specify in a graph and then ask the underlying output to do so. And also the last part is data telling. If you try to look at most of the time, people who kind of optimize at the lowest level, they worry about how to optimize it for the cache, right? Data locality. If you try to look at the power consumption from end to end, a lot of the power gets wasted just pulling the data back and forth. A lot of the problems that we have. And what OpenVX allows you to do is, since you're specifying a graph, now underlying implementation can look at it and say, I'm going to take maybe a chunk of memory in the graph and then process part of it, kind of a tile by, and then go back to another chunk, part of the graph. It has the flexibility to kind of use tiling to speed up the whole process. Let me show you a simple example how this code is done in OpenVX. It's going to look very simple, right? All you do is kind of create a graph and then you declare your input and output images. This is a very simple image. All it does basically is a Sobel. You dig a gradient filter, you look at how strong these edges are, you compare it with the threshold and saying, okay, all those gradients are not. Very simple problem, right? And how do you do it? First you declare your inputs and outputs, and then you specify all your intermediate buffers, that things that you don't really need to access. All you care about is input and output, right? And then you construct a graph topology. All you do is now you specify there is a Sobel 3x3 I want to run, where I'm going to give input, and then two outputs come out, horizontal and vertical. All it's going to do is a 3x3 filter horizontally and a 3x3 filter vertically. It's going to output two horizontal gradients and vertical gradients. And then you're going to use some kind of a magnitude, which basically does nothing but square root of dx squared plus dy squared kind of scenario. You get it one single magnitude, looking on that. And then followed by a threshold. You just compare the result greater than a particular threshold. If it is, then you say it's an edge, otherwise it's not an edge. It's that simple. Once you build a graph, now you have to make this call on VX verify graph. So what VX verify graph basically does is it gives a chance for the underlying framework to say, make sure the graph is valid, make sure there are no loops. Right? And also it's an opportunity for underlying framework to look at the whole graph now, try to see how well can it optimize, what all it can do. All the optimization techniques I covered in the previous slide, they can all be embedded. This is a place where all the graph compilation, everything happens. And once the graph is compiled, it is ready to run, then all you do is basically process graph or schedule and wait. You have, the goal of it is to make sure underlying hardware, implementer, optimize everything so the process graph runs really fast. And that is very critical for real-time embedded scenarios. You just take whatever time to initialize, and after that process graph takes really quick time to process. Now, when did we start working on OpenVX? I think it's about 2012, and we made our first release in 2014 1.0, and you can see a lot of conformant implementations there for 1.0 from a lot of vendors there. And we released last year May 1.1 release, and we added more functionality, kind of expanded Node, and then we also enhanced, we did some kind of cleanup in there to make the framework look good. And you see Cadence, Imagination, Intel, and in 1.0 we have AMD. You can see a lot of companies in there. NVIDIA, they have an implementation too. Last year AMD also released an open source implementation for OpenVX. So just to kind of promote the standard, it was a prototype that they created, which is kind of open source so that people can start playing with it. I have another slide to cover it. This year, we released 1.2. And what are the functionality that we added in 1.2 is kind of a conditional node execution. That's something where instead of just saying you complete data flows in graph, you could specify something conditional logic so you don't have to run multiple graphs. You can specify one big graph and you can make a decision whether to run feature tracking. Once in a while you're going to run, so you can specify that logic instead of that. And we added more functionality such as feature detection, classification operation, and we also released neural network extension as part of 1.2, and that's where you get the CNN functionality. In addition to that, we have a safety critical 1.1 that we released. It's mainly targeted for people to make the kind of implementer's job easy to take it for safety critical certification. When you go to safety critical certification, writing the code is probably the easier part. Just to verify that one, it's a very costly. Documenting is a very costly part. So how do we define an API so that that certification overhead is very low is a hard problem. And at Kronos, we try to come up with APIs for safety critical. We have one for OpenGL, and we're now working on OpenCL also. And we have the first version of OpenVX safety critical released this year. And what are we looking next is being able to, once the NNEF is ready, we want to be able to import neural networks directly from NNEF. That's one functionality we're looking at. And other functionality is OpenVX still is kind of young. It has a moderate amount of functionality, but it doesn't have a lot of functionality compared to OpenCV. So we want to provide a mechanism where users can extend in a way that it gets accelerated on the hardware. That's a hard problem. Given that the kind of vendors that we have, look at the architectures, you have CPU, GPU, some are FPGA, some are fixed function, with certain kind of programmability, custom logic. It is very hard to come up with one API and ask that everybody support that. So it's a hard challenge and we're still working on it. Also looking at streaming and pipelining, and if you try to look at embedded processing, a lot of times you have multiple processing, you don't want to submit one job, wait till the whole result comes, you want to kind of queue up the jobs, kind of run through a pipeline. That's one thing we're looking at. And if you guys have been using, are interested in OpenVX and want some features that are not listed here, and just feel free to contact me, or you can post it on Kronos. Kronos has a link called forums.kronos.org. You can just go there, feel free to post it. All the working group members kind of look at it, try to listen to see how they can address that. This is kind of sales pitch from my work at AMD. So we have an open source implementation. It's highly optimized for CPUs and GPUs. It's on GitHub. It's MIT license, so you can happily use it. There are two additional modules that are kind of interesting that I want to mention. One is a 360-degree video stitching software that we did, and you can see the kind of picture here. How many of you heard about Bahubali movie? Yeah, you guys, the media, yes. So they have kind of used built a camera, that 360 camera that has about 24, sometimes actually 28 cameras. Being able to stitch all those real time, live, and being able to see for preview, they even used it for broadcasting. It's a hard problem. So we kind of have that software. It's all OpenCL based. It's on GitHub. If you're interested, play with it. If you want to add more functionality, you can contribute it. And also recently we added a neural network extension based on MIOpen, that is the CUDN equivalent at AMD. It's again OpenCL based, so it's any hardware that supports OpenCL should be able to run it. And we have certain optimization specific to our hardware. It also includes some tools that can import and pre-train cache model into OpenVX. It's still at the development, it's very early stage. And we have a lot of, couple of interns, I think we have Stefan here, who's working on taking Loom and trying to make it work for 16-bit cameras. So a lot of work there. So if you're interested, look for it. If you want to play with OpenVX or neural network for inferencing, this is a place you can play. Now let's look at what functionality do we have in OpenVX 1.2. We added feature detectors, such as histogram gradients, LBP, and half-lines for line finding, template matching. We added we generalized some of the filters that we have. For example, direct load, earlier we had only restricted sizes. Now we made it so that the filter size can be any size, and you can even specify a pattern, like non-max suppression. And conditional execution that I was mentioning earlier. If you look at an example here, if all you want to do is if there's a condition A happened, then you want to execute the result from B or C. So you can kind of express that in a graph. It's a tricky one. We spent a lot of time trying to come up with an API that can be mapped to various kind of hardware. Now, any hardware can take this description. They will do it completely differently on each hardware. But the goal here is to how to capture application needs that they can express this in a graph. And that's what we kind of essentially look at from an API perspective. And we have import-export, which is kind of critical for safety critical, where if every time you build a graph, you don't want to compile it because compilation makes some time, take some time. So sometimes what you want to do is you want to pre-compile once, save that binary, and run it every time. Now sometimes you may not even want to compile it on the target system. You want to just, on your development system, you build your graph, you extract a binary, that binary you ship it to the actual hardware, then kind of what the amount of functionality code that you have is very minimal that you're shipping, and the amount of testing that you have to do if it's in a safety critical scenario is going to be also very little. That's the purpose of having this kind of import-export binary model we have. And for 1.2 neural network extension, primarily we're kind of looking at CNN functionality for the first release that we have. And basically, the way to look at it is each of the layers in neural network are represented as a node in the OpenVX. And they're kind of connected by a multidimensional tensor object. We define a new object called tensor. It can take up to 4-dimensional, very similar to most of the frameworks that they take. And the function that we have include like convolution, activation, cooling, fully connected, softmax, kind of functionality. I have a slide that gives you all the 8. And the beauty about this is now you can mix the neural network with traditional computer vision. So this kind of always depends. Some people just try to do everything in neural network, which can be computation expensive sometimes. And some people want to do some kind of pre-processing and then use that data, feed that to the neural network. Or you want to take whatever neural network gives to the computation detection, you want to use it to do further decisions in making other processing. You can use all that. You can use OpenVX to do those kind of operations. And yeah, we will be able to import LNEF in the future. This is just a small explanation of how these tensor objects are. You can see 1D just like an array, 2D is a 2-dimensional array, 3D is like a 3-dimensional, 4-dimensional. These are various kinds of shapes that you can have a tensor representing in there. And the math functions that we have is you can take a tensor, you can do very simple operations such as addition, subtraction, multiply. And you can also do kind of bit conversion. If you try to look from a real-time embedded low-power devices, they may not have floating point capability, so you need to support fixed function. So in our first release, we kind of constrained our requirements. When somebody claims they have OpenVX conformant neural networks, that just means that they support 16-bit fixed point. That means if you have trained your network to get fixed point weights, it is guaranteed to run. Some vendors will support other formats, for example, floating points. Now I think we support floating point because our hardware can do floating point. And how do we check the conformance? This is a tricky question when it comes to neural networks. You have various kinds of hardware. So the way we do it is we kind of define a tolerance. Okay, if this computation gets you error within this range, your functionality is okay. So we kind of guarantee minimum. When somebody claims it is OpenVX, you're guaranteed to get functionality within that kind of. And we have the APIs for each of the nodes are going to be, if you want to put a deconvolution layer node, this will be called VX deconvolution. Specify the graph and what is the input, what is the output, what are the deconvolution parameters. That it inserts a node into the graph for deconvolution scenario. So let me switch the gear for safety critical. Kronos, I think we've been working on OpenGL safety critical from very long, right? From 2005, 2003. And whereas they needed, if you try to look at flights, if you want to use some kind of graphics that uses OpenGL, and it has to go through some kind of a certification. And there are standards such as ISO 26262, which the automotive uses, and DO 178BC, which the aviation industry uses. So there are very strict rules. If you have to get a software to deploy on these devices because there's life under threat, basically there's life at stake if something goes wrong, there's a rigorous process that has to go through. They have to verify every line of the code. They have to have a test to check every functionality that's available in the code. So we kind of made the APIs easier for vendors to take and deploy in these kind of scenarios. And Kronos also has created a safety critical advisory panel, and mainly to get feedback from the industry, from the industry experts, so that we can incorporate them into new standards that we keep creating every time. And yeah, I think I mentioned this before. Safety critical OpenVX 1.1 spec we released in May, and to do this one we had to go through kind of MISRA-C compliance. We just ran through the header files to make sure there are no warnings, because every time there's a warning or something like that, we have to give a justification. Every vendor has to give a justification. That process gets complicated and expensive. So how do we create our API so that it is less work for implementers to make their code safety critical compatible? I'm going to skip that. And the safety critical spec was mainly based on 1.1 main spec. What we did, we enhanced it so that it is very deterministic. When it's a safety critical, you cannot have words such as functionality is undefined. If you pass a value outside this undefined, we cannot specify those. Everything has to be very deterministic and very well defined in the specification. And what we did is we identified every key requirement. We numbered them. So an implementation can go and say they have tested each and every of those requirements by the numbers that were there. And also we split the specification into two parts. One is called a development and a deployment. And deployment is where the safety critical part is very essential. So what the development part does is you kind of define your graph or whatever functionality you want, and then you verify the graph, and then you export a binary. And that binary is kind of very vendor specific. And on the deployment side, all it does is it takes the pre-compiled binary, and all it does is just execute them in the order that is specified in there. And now that reduces, we don't need any graphics here in terms of adding nodes and all that. So a lot of functionality is removed. You have basically an import and run functionality. That is few set of functions. And that kind of makes the job a lot easier for people to take it to the safety critical scenario. So earlier there was a question about comparing between OpenVX, OpenCV, and the people who ask OpenCL. Now, if I can accelerate all my vision functionality in OpenCL by using OpenVX, kind of, it's a very loaded chart. So few key things that I want to specify is OpenVX is an open standard API designed to be implemented and shipped by hardware vendors. Right? They kind of implement it to the spec and then they ship it. When somebody claims it's functional, it has the conformance model, it is guaranteed to function across all the hardware. Whereas OpenCV is a community-driven and open source library. So it has a lot of functionality going in there. OpenCL, on the other side, is more of a language and an API that people can express their algorithms in to get it accelerated. So it does application, basically if you want to write a particular algorithm for vision, you have to write everything from scratch. Vendor doesn't do it for you. All they do is they take your acceleration and speed it up. So in any case, what we did, we used OpenCL to accelerate our OpenVX. If a user wants to accelerate their own custom nodes, they can use OpenCL, wrap it, and then call it as a node. It's a particular vendor extension from AMD. Now, what are the benefits? OpenVX basically allows you a faster development, and especially it lets you build an application that is portable functionally and also performance portable. Those are the key features that we kind of look at. Every time we add a feature, we make sure that API is portable across hardware and is performance portable. That is, if an application developer looks at it and says, this is the best way I can write it in terms of expressing it into intermediate buffers. And there's no, application doesn't have to specify any platform-specific optimizations. That's the key of it. And underlying implementation will take care of scheduling, memory management, all these techniques to optimize it. And here are some of the links for resources. You can go to kronos.org/openvx. The spec is available on the registry. And if you go to the resources, you will find links to existing implementations. You'll usually find a link to AMD's open source. You'll find a link to Intel's, NVIDIA's, and all the vendors who ever have something. And I also kept a link there for the tutorial, OpenVX tutorial, if you really want to dive deep into API tutorials. So we did give a workshop at Embedded Vision Summit in May, and we have all the videos and all the training material available there. If you're interested, just look at it. And I have a GitHub project where all the source code material is about, exercises are about that. I'm going to skip this one. In theory, it's basically saying that there are other standards that of Kronos that vendors can use to implement OpenVX. So that's pretty much it. Sorry, I didn't want for the last slide. That he's the president of Kronos. If you have any questions, you can send it to him or me or post it on the Kronos forum.
I'm just curious whether OpenVX actually supports this object detection, segmentation, and I think RCN and those types of.
We don't have RCN in the current spec. We are working on that. You will find those functionality in the next release.
Do you have any performance data to compare the OpenVX with the other standards, and especially also running in CPU versus, for example, GPU, or make sure of different clusters?
So one thing we don't have the OpenVX benchmarks. Oh, sorry. Okay. The question is, are there any benchmark, any performance numbers to compare OpenVX with other ways of implementing and comparing performance between CPU and GPU? So in the industry, there is no standard benchmark that people have defined yet. But you can always play with. You can look at our open source. I have an example where it is a simple skin tone detector. If you have to implement that using OpenCV, you have to make a call every time and wait for the result. In OpenVX, you specify the whole graph. It looks at the graph and tries to generate a one kernel, OpenCL kernel. It generates a code, and that runs really fast. Right? You can look at some of the examples that are there. And it also looks at, if you specify this number example for tracking, it kind of schedules part of it that is CPU friendly on GPU, part that is friendly on CPU. It moves to the CPU and kind of schedules it.
Kronos has a design for computer vision, and then we use the others, like natural language processing, come up with.
So, yeah, the question is, currently the Kronos defined for computer vision can be used for natural language processing. So, if you look at the neural network part, right, and there is no RNN yet. But in terms of, if you try to look at the data, if you look at the data, input is a tensor. We have tensor object. So in theory, you can specify your input that's coming in audio as a vector and pass it to the neural network. When we have RNN and LSTMs, yes, you can achieve that functionality.
So, you can NNES with sort of portable format of defining your network and you showed us the many problems in the beginning. So, since NNES is not there yet, how does OpenVX support these multiple different platforms at the moment?
Yeah, so the question is, NNF is not there, and we have this many problem. How is OpenVX addressing today? That's a question, right? So I can tell you about two implementations that I know, right? Intel ones and AMD one. We both basically have our own tools that we build, which kind of, you can take a predefined cafe model, we import it into OpenVX, we generate code. Right? There's no standard yet. OpenVX is still not there yet. We're kind of trying to promote this idea, kind of spread the word, and try to get more people to use this and adopt the standard. It's going to take some time, but I think eventually that's what is needed.
This was also notable absences in the last department. Like, what is the traction with Google and Facebook throughout,
The question is Google and Facebook, what is their traction? So Google is big and they have invested so much money on TensorFlow, and we would love them to come and participate or at least help us. By the way, Google is also a Kronos member. But we haven't gone to that level of, once we have the spec out is when we want to start talking to all these people and trying to see if there's a way to export and import. All we need is export and import functionality. That's a simple problem compared to what Google does. It's really big.
So that brings the next question. So do you guys already have any NNEF sample execution where you know the size of the graph, it increases or decreases compared to say TensorFlow?
Well, NNEF is not out yet. We're still working on the spec. We're going to release it end of this year. Right.
There is no like sample code which you have executed parallelly?
No. So what as part of the spec, what we're going to do is we're going to release kind of a validator, syntax validator. So people can use that as a tool to kind of read and check to make sure the data that they created is kind of conformant or not.
Because today the problem, at least I see, is like the size of the graph cannot be loaded into an embedded system so easily. Like NVIDIA GPUs, I don't know, AMD GPU. So you need like these bulky GPUs with like gigabytes of like dedicated memory. So that's a big problem if you want to productize any neural net on an edge especially.
What kind of network you're talking about?
So I'm talking a simple CNN, which has like 500 layers. Then the graph is not so small also, right?
But I think I looked at some example recently. Right? I have basically a huge network, right? And there are all intermediate buffers in there. When it goes inference, we specify it as a graph and tries to reduce the memory needed. If you try to run it in something like Kepler, for example, it may not optimize that. It may say I need 8 GB or maybe 16 GB hardware, and that's going to be expensive for somebody to use. And you run it through OpenVX, it may just optimize the whole thing away, and then maybe you get it less than a GB of memory. Yeah. I'm sure if you look at TensorFlow, they would do the same thing too. It's hard for me to imagine there's an inference engine that doesn't do that kind of optimization. And all we're at OpenVX we're saying is, all these APIs, individual APIs, can be mapped directly from OpenVX. If you write at OpenVX, any of these inference engine can be plugged in underneath, so that there's one API to reach out to all these inference engines and hardware.
you specifically looked at the transfer learning aspect of it in the standards. The transfer learning aspect.
Transfer learning.
Transfer learning for neural networks. Say someone has already trained neural networks. So one of the things that many people does is they do a transfer learning, so that the initial stages of the convolutional neural network, that those weights, those pre-trained weights come in, and then they train the rest of the network. So that is often used in the industry. So have you looked at the transfer learning aspect of forks and variations?
Not exactly. Maybe I think that is the question completely. So by transfer learning, you mean you just pre-train it,
Yes.
and you use it. You talk about RNN scenarios.
The Googles of the world has tremendous resources. So what they do is they take the related data and then they train like the Alex name, the BGT nets, etc. Right, the Google nets. So what many of the PMOs in the world like us we do is we take those different neural network weights and then we just train the inference or I would say the full layers of it and some data to right. So that is the transfer that we do, right?
So if we go back to my early
Can you
slides.
please repeat the question?
Yeah, I will repeat that. Sorry for the slide. Yeah, if you try to look here, so this question is transfer learning. That means you already pick if you already have a network that somebody has already invested some money, and then it's pre-trained with certain image data. Now you want to take that and then retrain certain layers, or basically you want to do some refined training there. Now, if you try to look at the problem here, so you already went through that, you got a trained network model. You want to take that model and then try to train it back. That means you have to export it back into TensorFlow or Caffe, and then being able to use that to retrain that model. So the fact that NNEF is an intermediate format, you can import and export. In fact, it may be imported from, let's say, TensorFlow, but you want to use it on Caffe. You brought a good point in the sense that sometimes they don't map directly one-to-one. You have to make compromises.
Exactly.
So what NNEF lets you do is being able to represent whatever the framework means, whatever the intent is, you can express that in NNEF. But now when you try to export it to another framework, that's where you need to put your own intelligence. This is basically pure representation. It's a data format. All it lets you do is any network that comes from any framework, I can represent it in NNEF. That's a tool. Right? So you don't have to worry about learning 10 different data formats.
So the one-to-many part of the problem that you talked about, like multiple inference engines, when you already have your application in OpenVX. So as you mentioned, that is how OpenVX addresses that issue, like the scheduling, the current fusion, memory management, and all of that. So from somebody who's working to support a new platform on there, what kind of tools does OpenVX provide? Like how do you have to all of those frameworks that need to be mapped into a particular hardware?
So the question is, all the optimizations that are possible, what tools are available for OpenVX for somebody to implement? The way I would answer is, from the Chrono standard, all we produce is a specification and a conformance test. So we basically give you header files, you implement the .cpp, and then we give the test, you run those tests, and the test will tell you whether your code runs conformant or not. And in terms of who will do that is mainly the hardware implementers, right? AMD will implement it, and if somebody has a DSP hardware and TI, they have their own implementations. You see the big list of people they have. And everybody optimizes them differently because they're different architectures. They use different techniques. Whatever I listed are basically high-level concepts. But if you dig down, you'll find some of the techniques are very unique to their own platform. Did I answer it?
So this graph optimization, is it done by OpenVX at some point, or is it all left to the hardware vendor?
All left to the hardware. All OpenVX tells you is this call called VX verify graph that you have to call before you run process graph. And that's a placeholder for the underlying hardware driver. Kicks in and says, okay, that looks at the whole graph, try to optimize everything that it can. Basically, it gives you the freedom as an application developer. You don't have to worry about on which hardware I'm doing. You just write to that API, your application is just ported across. Any other questions? Yes.
I look at this and I look at the rapid rate at which neural networks and deep learning are racing forward, and I both admire your bravery and your energy in trying to semi-standardize this, and I'm worried that we're so early that it will prove short-lived. Maybe it's fair to compare this with the history of scientific computing going back decades. I look at that and how many attempts there were and how short-lived many of them turned out to be, so now they're software in peaks. Do you have some insight that will allow you to do better than our forefathers did?
Okay. It's a hard question.
Yes.
So let me give you an analogy here from the graphics world. Right? If you go back early when there is graphics process are new in the market, right? You have SGI, then multiple people start coming in. we needed an API that application developer doesn't have to worry about writing the code for each and different hardware graphics. That's why we came with OpenGL at Kronos. And everybody started implementing that API that made the game developer's job a lot easier. Now, it is not just coming up with an API. Now, they also came up with data formats for Collada. It was a data format in those days. Now, GLTF has taken over that. Being able to express, the texture data or the content underlying that, so that the content producers, basically the artists, can export their data in that, and game engine can just take the data and do it. I kind of see a very similar paradigm here. You have all these vendors building the hardware, just like graphic processor for neural network execution. That's the machines on which it's going to run. And I can't imagine somebody from the top level, the third-party company, knowing how to optimize all this hardware. Who knows best about the hardware? Are the hardware guys. And if we agree on a standard API where application can express, if you try to look at the neural networks, these are operations are very simple: convolution, activation, these are standard operation. There are little variations coming up, but still they are very well defined, similar to what graphics has. And you need a format to exchange the data, the weights that are coming from. So I think now is the time, because everybody started building new hardware. If there's only one hardware vendor, you have a profit.
If I can just add to that, I mean, APIs are not necessarily have to be a static thing. Right? There will be different versions of the API as your hardware gets more mature, and also the functionalities are better understood. They will be reflected in the future version of the API, so it's not a static thing. It's version 1, version 2, version 3, continues, right?
Yes. Yeah.
One question on these OpenVX. So if you mentioned in one of your slides that there is a certification process, conformance certification process. So is that like administered by the Kronos?
Yes.
And it's a guarantee what? It's a guarantee that.
So in order for somebody to use OpenVX logo, to say that I have an OpenVX implementation, my hardware supports OpenVX, they have to go through an adapter program where they take the conformance test that we have, they run through it, and they submit the logs, and then Kronos looks at it and says that yes, all those tests are passing, so you can use the logo. So when somebody says they use OpenVX logo, you are guaranteed that certain level of testing has been done.
So I can develop my software and expect that hardware to be
Functional.
functional completely without, and Kronos will take that responsibility. Sure.
Kronos won't go test everybody, but when somebody uses the logo, right, they are agreeing that they have tested everything. They submitted correct log file. If somebody cheats, I think nobody's interested in doing that.
I was thinking about an implementation where you have multiple vendors, processors together putting a system.
It's the same thing like in Windows. When somebody says they have Windows compliant driver, so you have different kind of audio cards involved, all this, multiple graphics audio cards. When you plug in, you write your driver to that API, it works. If it doesn't work, people don't buy it. Right? At least they certify this Windows certification process. Similar to that, this is Kronos way of saying if you say you're OpenVX or OpenCL, you're guaranteed to support that functionality. That's this one.
So that brings a question like the neural nets are going to get complicated over years, right? So what's your release schedule like? Like you have to catch up with the new neural nets that are going to come, right? We don't know what innovative and creative people can get, right? So is it like yearly or like half yearly? Like how is it?
So if you look at the OpenVX part, on the acceleration part, we've been releasing every year.
Yeah, what about the NNEF part?
NNEF, so
I know it's too early to ask this,
right, but the goal here is we are trying to come up with a representation that is very general. So even it has ability to represent some of the functionality that can be featured. It's basically you're defining operations in a particular syntax. You have predefined operations, and there are custom operations that you can specify.
Yeah. Sometimes I have seen like at the end of say a CNN and RNN, there can be an LSTM sitting, right? If you want to optimize, like a real world scenario. So the standard will take in even those kind of.
Yes, So NNEF is not constrained by OpenVX. NNEF job is to say whatever any of these frameworks can represent, can have, I can represent that in my format. OpenVX is different. It says that I'm only addressing low power embedded devices there. Yes.
So looking at your list of supporters, basically of the opinion that this software only runs on engineering workstations of engineering servers. And that if like there's no IBM up there, there's no Oracle up there, right? There's no Kind of Enterprise up there. And so your first deployment doesn't really concern any AI on the enterprise.
So if you kind of look at the problem from layers, right? Kronos only looks from silicon to software, like the way it states, right? What we do basically is enable software to access hardware acceleration. And the level that you're talking about probably is much more higher. They kind of use this low level. You're probably looking at enterprise applications, which are a couple of layers above these APIs.
So you have advisors that talk about trying to use AI at a higher level?
Advisors to talk AI at high level? Not that I know of. Not that I know of. But if you're interested on neural network exchange format, if you have some kind of expertise that you want to share, yeah, we would love to welcome you to Kronos. But again, it primarily looks at the primary motive there is to make it kind of come down. We're trying to solve the low-level problems. Kronos is trying to solve low-level problems. Did I answer your question?
Yeah, it's out of scope. The question I asked is out of your scope.
Can you comment on the difference between using APIs and maybe using a domain-specific language?
APIs and domain-specific language?
You can develop a language for describing neural networks, which would be more flexible than an API becomes.
So, describing neural networks is domain-specific. If you try to look at, cafe prototypes, if you consider that as domain-specific, to me that's like a data format. Right?
Just curious, Google joining this, so does that mean TensorFlow is somehow going to morph into this thing?
No.
Or they're actually
Google is not participating in the NNEF part, but Google is currently active in Vulkan and GLTM, that side. It's a member of Kronos, but it's not active in NNEF.
So is this competing with TensorFlow?
I don't think so. We're not competing. It's just that once NEF is ready is when Google can say, no, all Google has to do is export it to NNEF. I report from NNEF. That's kind of edge functionality, so it's not a big deal. As long as you can, whatever you can put in TensorFlow is represented here, they should be fine. It's not in their interest yet. They don't see this problem. That's my assumption.
So how is the media embracing the idea of open revenue? So it looks to me that so can you go back to the slide for the supporters for the
OpenVX supporters. That's a lot of slides. This one?
Yeah, so is NVIDIA actively involved in development of the standard, and what's their progress on developing their hardware specific compiler? It's basically.
So you can see NVIDIA has a conformant implementation. In fact, NVIDIA has one of the early releases. One of the early adopters of this OpenVX.
So they're also actively pushing their
You
standard.
can go to the Kronos resource page. You'll find a link to NVIDIA's implementation. Everybody's implementation. You'll find a link there. Yes, you can use that.
Thanks.
Any more questions?
Yeah, a question about the graphic scheduling. When different nodes can be accelerated by different pieces of hardware, can that be specified through the API, or is that just based on the underlying implementation?
Okay, so that's a good question. So graph scheduling, right now, when the graph compiler implementation, for example, I can answer it from AMD side, right, on our open source implementation. You specify graph, kind of look at the whole graph and try to see which parts are run efficiently on CPU or GPU. You kind of decide that looking to doing the graph compilation phase. And during that phase, we decide where to execute what. And if you take something like, another DSP SoC where you have a DSP part and ISP part and a post processor, and you might do it differently. You might look at some parts such as, if you're doing simple filtering, you might say, I'm going to use ISP because ISP is very efficient at doing it. And there's certain functionality DSP is good at. So they'll kind of schedule it based on, there's a lot of domain-specific knowledge that is specific to the hardware that is needed. Now in terms of the question, can a user specify where they want to execute what? It is very hard to come up with an API because if you like to look at the portfolio of hardware, we have all kinds of hardware. So we could not come up with one, but we have one call that said set node target. And you can specify a string. What you specify in a string, we don't know. That may not be important. Yes.
As a follow-up, can you specify operating system commands that also optimize? So you can say, I want, all of this stuff has a lot of cache traffic, so you guys should all be on one CC node, right? So a CC movement command and a CPU command in Linux basically allows you, and don't swap me out. Those are real-time command systems, swap me out. And so can you specify those things which allow you to at least achieve the sysadmin level of performance?
Primarily the reason, the question is, can you specify at high level, right, in terms of scheduling, whether you want to keep this node always on this particular node. OpenVX does not specify any at that level. The reason is primarily because prime motive of OpenVX is functionally portable and performance portable. So you write an application, you don't have to worry about what hardware it is running on. You want everything to be taken care automatically by the underlying hardware. The moment an application says, run this particular node on DSP, now I try to port that code, try to run it on PCs, there is no DSP. What is it going to do? Is it an error? So you want to kind of specify, the fact that you kind of specify functionality to a very high level abstract is good enough for most of the functionality. We haven't come across a case where a user has to explicitly say. If there are use cases, yes, we will accept.
But sometimes, for example, you want to run inferencing on the GPU. So you don't have enough GPU capacity for running computer vision. So you want to specifically run the vision programs on CPU. In those cases.
So if you look at AMD's implementation or open source, I have something called affinity. I can specify for each of those nodes affinity whether to run it on CPU or GPU. But there you're using AMD's vendor extension. That application, if you try to compile it and run it on, let's say, some other DSP, there's nothing called GPU affinity or CPU affinity. They haven't implemented because it is not a standard. So if you want to specify something very standard, you have to go through standard way. If there are certain things that are extensions, for example, then you have to look at, is this hardware, am I running on a PC? Then I make these calls. Am I running on some other processor? You can extend it. It depends on vendor implementation. But at Kronos, we don't want to specify that are not portable across vendors. every vendor will do something, give you some control. If a user needs it, they will give a control.
Well,
let's assume we have the targeting machine is with Intel CPU, has its own FPGA and also NVIDIA GPU. So I think it will be proper to choose which compiler will be used, right? So either use NVIDIA OpenVX compiler or Intel. So that's just up to each hardware vendor to decide how to harness their
That's an interesting question. So when I build it, let's say if you're building a system that has hardware from multiple vendors and you want OpenVX to schedule across all of them. Now, the way I see it is not the individual hardware vendor that is responsible for it. Since you're building a system, you are an OpenVX vendor. Now you have to implement an OpenVX that takes advantage of all this. Then acceleration is possible across.
So you mean so there is hardware scheduling function inside the OpenVX. So the basically user has to choose where to deploy their
not the user, the hardware. Whoever is driving the OpenVX driver has to do that. Yes.
Is there an OpenVX file editor? So
it sounds like you can't get platform-specific optimizations without actually hacking some file. And that's fine, because you didn't say, you said platform independent. But if you want that 10x performance improvement because you bought the hardware, that means you have to hire an expert in the internal file format so that you can get the kind of targeting that these people are talking about. And I assume that you have an internal description of the file data format and a programmer's guide about how to hack the file so you get what you want on your platform.
Are you talking about neural network weights? When you say file format, what are you talking about? Data format?
So the file has a list of nodes.
This file has a list of nodes and a list of weights and a set of computations to perform, right? But it doesn't contain the platform-specific optimizations. So it doesn't include CC NUMA command, and it doesn't include any kind of graphics target command. And so those things, you have to go into the file, you have to understand how the file works, and you have to insert a few lines which says, send that part of the program over there. And I was just wondering, do you have a programmer's guide for the intermediate file? Because that's your whole point, is the way we achieve platform independence is that everybody creates this intermediate file that everybody else can read, right?
So, okay. I'm a little bit confused. So the two parts here. So one is, when I say intermediate file format for an NEF, that is describing the neural network structure and the weights that are in it. That
You have to speak a little louder, please.
How about now? Can you hear?
A little better, thank you.
Okay, so in the NNEF case, you can describe the network topology and the weights in that format.
Yes.
When somebody takes that, the topology structure has no information about where to run the convolutions. It simply says run a convolution, followed by pooling and activation, and that structure. All it defines is that structure. Now, all the implementations that are there for inference, they almost try to get 94% of the hardware utilization possible. That's the theoretical. They want to kind of get the peak throughput possible for the whole description.
So
it doesn't have to go and say run this convolution on DSP and ReLU or something else.
Okay, I may have made a mistake. I assume since all modern systems are multi-core, you could specify, or in some way, I'm going to use 6 cores right? And I can't specify which 6 cores in the file, but the program inherently parallelizes the process. It may not do that. It may be a single core application.
Okay, so if you're talking about, so basically you want to be able to say what hardware resources to use when running this graph.
Right, so if I spend, $50,000 and I have the God awesome engineering workstation, I would like to be able to say, I would like to be able to add to this program, OpenVX, in a way which says, this is how I think this will work best, and it will run 10 times faster than anything else that costs $5,000. Sounds about right?
Yeah, so I guess then the responsibility is with the OpenVX implementer to provide an extension for you for that particular case to say where do you want to map it to. But it is very hard to specify, define an API for this use case that is maps across all the hardware. No, remember, we have some custom hardware vendors. We want to use the same API. What does it mean to say run it on these cores?
Okay, so if I have a 16-core system, it's entirely possible that the out-of-the-box version of OpenVX doesn't know how to use more than 4 of them. Oh.
Yes. If somebody made an implementation like that, that's an implementation limitation.
Okay, so
who would implement an OpenVX that doesn't use the hardware? If I'm selling the hardware, for example, right, from AMD, when I give an OpenVX, I want to make sure it uses all my hardware capital. If it doesn't, then
yes, but in order to do that, it has to know something about the software platform that lies underneath so that it can know what commands to send to the operating system about.
That is up to the OpenVX implementation. OpenVX implementation takes care of that for you.
So does the test suite have vendor implementations extensions?
From a conformance perspective, we don't care at that level. We simply say, when I ask you to do, let's say, Gaussian filter, did you do Gaussian filter or not? When I ask you to do, let's say, CAN-EH, did the output come correctly? When it comes to performance, there is no way to standardize that.
Okay, then what I would expect is that OpenVX will be a great opportunity for professional services for decades to come.
The same is true for WebGL. Today, WebGL is used everywhere. All your phones have WebGL.
Okay, just understanding the lay of the land. This is not AI for dummies. It's okay, because there are no dummies in this room, but, just being clear.
Yeah, this is for low-level programmers, yeah.
All right, so I think our host is getting ready to go home. But again, please give a big round of applause to Rhonda for a great talk. And if you're interested in various types of WISE technology, I know how many of you have been following LoRa, 6WOX, and NP-IoT. So the speaker next month will basically go over all the different types of WISE technology for IoT devices. It's going to be a very interesting talk. So I'll see you next month. Thank you.
Yeah. One is beautiful salad and the other is have either one. I admire your bold. Are you funny? How is it? So you do it for the CS? I saw you.